Good morning, everybody. Thank you, Michael. It's good to be back here again for the second time. I was here last year in Oxford. You might remember, for those of you that attended, I was presenting our concepts for Cubesats on our asteroid impact mission. I've got two presentations today. The one this morning I'm doing in collaboration with my colleagues in the Lunar Exploration Office in the Directorate of Human Spaceflight and Robotic Exploration. Myself, I work in the Technical Directorate in ESA at ESTEC, and I'm responsible for the implementation of Cubesats for technology in orbit demonstration. So we have a good collaboration going, let's say, for these types of things. So, LUnar CubeSats for exploration. We basically started this initiative earlier last year. To be frank, the flight opportunities for going to the moon in the past years were not so significant, but as you've heard from my colleague Tony, SLS and the Orion system is offering a ride for a number of CubeSats to the moon in the coming years. We at ESA were asked by our NASA colleagues at that time, in Europe, do we have any lunar CubeSats that we could fly on that EM1 mission? We didn't have so much at that time. We were not prepared with the concepts and developments in place. So that actually led to us initiating a Sysnova challenge on this particular subject in order to prepare mission concepts in Europe to take advantage of lunar flight opportunities rising in the future. And some of you may know our Sysnova challenge, but Sysnova is part of our General Studies Programme in ESA. It's there to survey a broad range of different technology and mission concepts. Doesn't have to be CubeSats, it could be anything, but addressing a specific theme. So this is our fourth Sysnova challenge, and this particular theme was addressing how could we use CubeSats at the moon for science purposes and supporting actual lunar exploration efforts in the future. So, generally speaking, our Sysnova challenge is there to be able to conduct these advanced studies, look a bit beyond the current ESA programs to make preparations for the future, facilitating collaboration and close working between industry and academia on these types of concepts, to assess the technologies and actually come out with a plan for technology R&D efforts which will underpin the realization of these systems in the future. And we also like to look at, of course, technology spin-in, and that's particularly relevant for looking at COTS components and products, how we can utilize them for these types of small miniaturized missions. Specifically for LUCE, Lunar CubeSats for exploration, as we called it, we basically challenged the community to propose lunar CubeSat mission concepts. Actually, there was a huge response to the open call we had. Very, very encouraging to see that. And it took us quite some months to evaluate all the proposals. But finally, we arrived at a selection of 4 proposals, which we have now awarded contracts for the further study. You will see actually 2 of those concepts being presented here this morning in the workshop. And basically, those 4 concepts that have been selected for further study, we received actually many more good quality ones than we could actually award from a budget point of view that we needed before. Those 4 are going to be further studied now over the next few months, and we will actually have a workshop in December to select a winner, and that winner will receive actually a prize. The lucky winner is going to get a CDF study, so they don't get any cash as such, but they get our experts in the agency to work with them to further mature their concept. Technologies to be addressed then in the LUCE Sysnova were quite numerous, particularly regarding deployment and autonomous operation of small sats in lunar orbit, particular emphasis on autonomy, as we'll see in a moment, miniaturization of scientific technology payloads, particularly for technology flight demonstration to be used in other future interplanetary CubeSat missions. Other technology would include instrumentation that could conduct science operations that we really haven't seen in the past for the Moon. So the challenge here was for teams to propose something that actually hasn't been done before in terms of lunar science. And of course, CubeSats, as we know for deep space and interplanetary missions, need to communicate back to Earth, and this is really assuming the availability of a larger communications orbiter asset in lunar orbit. So technologies to be addressed there include inter-satellite communication links. So we challenged the community to address 4 different sub-themes in the Sysnova, including missions addressing lunar prospecting, so looking at lunar resources on the Moon to see what would be available to support future human surface operations, characterizing the lunar environment, again with one mind on the hazards that presents to human exploration at the Moon, technology demonstration in support of exploration, not just technology demonstration for the sake of it, and actually conducting science from lunar orbit. So looking at the constraints here, we put into the core an assumption, of course, as I said, for communication with the lunar orbiter, this larger asset which would inject them there also provide relay capabilities. The assumption here was that other operations were going on with that larger lunar orbiter, and the availability for CubeSat communications would be on the order of 1 hour per day, no direct-to-Earth communications. The overall mass capacity assumed that could be injected for the CubeSats would be a total of 60 kilograms and a maximum of 24 kilograms each, so anything up to 12 units CubeSats. And we allowed proposals from any concept which could be injected into an altitude of larger than 500 or higher than 500 kilometers circular altitude, and there's a higher altitude inclinations as well. So a high amount of autonomy would be required, and particularly not only the 1 hour per day for nominal operations, but in case of contingencies, survivability for up to 10 days without ground contact. Just to present to you now the 4 concepts that have been selected. I won't go into great detail about this one, because you'll see it much more detail later from our colleagues at Politecnico di Milano, who are leading this LUNIO concept, as they call it, Lunar Meteoroid Impact Observer. Just to say here that the main objective is to actually measure the meteoroid impact flashes on the far side of the Moon in order to build up statistics and models for meteoroid hazard analysis for astronaut exploration of the lunar surface. This is all to be complementary to near-side observations that, of course, can be made from the Earth. So this would be actually taking new data relevant to exploration as well. The main payload here is a camera. It's something which is taking high frame rate data in order to detect and autonomously process and acquire impact flash information on the lunar far side. And you can see the specifications here of the order of 3.4 kilometers per pixel. Doesn't need to be particularly high resolution, but we just want to locate the particular flashes of the impacts to a certain degree. The mission concept itself, just not to give too many spoilers, but just to say it's a single CubeSat 12U that would actually transfer using propulsion to an Earth-Moon Lagrange point to halo orbit, so actually permanently viewing the far side of the Moon, take observations from there. Then we have another one called MoonCare, that's led by Von Karman Institute in Brussels and involving a number of organisations. That stands for CubeSats, for the analysis of radiation environment on the moon. Here, the main objective is to characterise the effects of the lunar radiation environment on different microorganisms. And although these will be non-human life forms to be analysed, there's a particular interest in biologically regenerative closed-loop life support systems. So what would be the radiation effects on the bacteria that are actually closed-loop life support systems? Are there any degradation to be expected there? So it will actually carry a radiation detector to measure high-energy particles, and a moon bio experiment, which is consisting of a multiple sample container, spectrometer, and a UV spectrometer, and various electronics to drive the payload. And we aim to have 4 different microorganisms there on the mission to be analysed. And that actually measures then the growth of those cell cultures, and that's then compared with control samples back on Earth. Here the proposal is to have a number of 6-unit CubeSats, and that's mainly to characterise the variability of the lunar radiation environment and therefore feeding into the effects on biology. The third concept is CLE. Again, that's going to be presented this morning, so I won't go into a lot of detail, but similar to, as Tony mentioned in his talk, this is a low-frequency radio astronomy observation demonstration mission. So there's a long-term goal by the consortium you see here. It's mostly a Dutch consortium of ISIS, Astron for the science point of view, and so on. Their long-term ambition is to actually have a low-frequency radiometric interferometric array consisting of several tens of small spacecraft, actually forming a distributed aperture. This mission will actually be a demonstrator for the system capabilities, so it will be consistent of 3 12-unit CubeSats, actually demonstrating them in lunar orbit, particularly over the far side of the moon, the radio quiet zone, to actually take the low-frequency radio measurements and actually then transmit those over into satellite link to mothercraft, which actually is then doing the metrology for the baseline measurements on the satellite distances for the array. So all of that is to be demonstrated, and that's particularly addressing cosmology with the dark ages of the universe, looking at the energy distribution of radio galaxies and massive black holes. But also, as Tony mentioned, there is also a plan to use these types of arrays for looking at coronal mass ejections from our sun, so-called type 2 bursts, and this will aim to demonstrate the system for that. So as I said, 3 12-unit CubeSats, 20 kilograms each, linked together with ISLs, ranging capability, timing synchronization is very important also for the interferometry, and propulsion also to maintain the LUCE formation constellation. Fourth concept is VMMO, Volatile Mineralogy Mapping Orbiter, not unlike the lunar flashlight concept, which was presented by Tony previously. This is led by MPP Communications in Canada, based on their heritage of fiber lasers. And the main payload for this is actually a fiber laser operating on 2 different wavelengths in UV vis and near infrared, aiming to give a ground sampling distance of around 10 meters from a low lunar orbit. The main aim here, as you can probably imagine, is to characterize in situ lunar resources on the lunar surface, particularly in the shallow regions of the poles and the craters. There is also a radiation environment sensor there as well. That data is going to be used to support future surface operations, human exploration. Particularly here, the main aim is to actually manoeuvre down to a lower altitude of around 100 kilometres. So there's quite a high delta V requirement here, so the team is looking into that in terms of which propulsion system can be used for that demanding delta V. Just briefly on the schedule, whenever we have a Sysnova, there's normally a period of 12 weeks between issuing the AO and selecting the different studies for kick-off. The 4 parallel studies now are going to be taking place over the next 7 months. December we'll actually have a workshop, as I said, and we'll select the winner. So, just in conclusion, really, we were actually very surprised about the high number of high-quality proposals we received. I think that far exceeded our expectations. I won't give a precise number on that, just to say, beyond the 4 we've awarded for further study, there are a number which didn't win, but will still be very valuable in their own right for flight to the moon. And although those 4 are being studied and we'll select the winner, it should be said that when we get future flight opportunities to the moon, we will actually have a specific AO for that flight opportunity. And it may very well be that other concepts also win the seats to the moon as well. So this is just the start of the story for us. And we hope to see more going on in this area in the future. And we also hope, of course, to underpin the community and support them in their conceptual development and technology development and eventual missions later on. And for us, it's been very pleasing to see that as a member actually science, academic partners with industry partners working together very closely to actually do something in this area. So I would just say, from our point of view, we hope to see this happening going on in the future. Sorry about that.
So, any questions? Okay.
Hi. So, do you have a plans for extending this challenge to Mars?
Not currently, but never say never. I think the Sysnova challenge, it's there, and we use it on an annual or biannual basis to actually look at different themes. So I think if we can see that there is some potential there, and I mean particularly interest expressed by the community, then we'll look at putting a challenge in place. We have actually done some studies on CubeSats and Mars, a little bit connected to my presentation this afternoon. But I think we recognise there we are quite reliant on piggybacking on the actual Mars missions, like landers and orbiters and so on. So it may very well be the case in the future that we have a challenge on that.
So you said there have been a vast amount of high-quality proposals, but you also said that the winner gets a weapon or like some engineers, whatever. So as there is a lot of quality in CubeSat missions in Europe, does ESA intend in the future to finance or to have like a budget particular for CubeSat missions or for any CubeSat deep space exploration?
I think it's a very valid question. We do fund a number of CubeSats in our technology programme, and that would be one channel by which to put funding in, particularly when, of course, we're demonstrating new technologies, which may be useful also for low Earth orbit as well as deep space. That would be one area. Of course, we have lunar exploration office in our Human Spaceflight and Robotic Exploration Directorate. And they're actually, of course, conducting their own activities for participation in partner missions as well. Lander has been proposed in the past, as you may know, so that is another channel for funding these types of missions. We work closely with them, and those will be the two options to look at for funding.
That's like particular for like research goals, somewhat. So, but there's no intention of funding like rather deep space or like CubeSat exploration. So it's all driven by specific scientific goals, right, around the ends and your world.
Well, so far it's not been so science-driven, I have to say. We have done, talking this afternoon about my presentation on the asteroid rendezvous CubeSat capabilities. We're still at a stage, I think, where the technology needs to be developed and demonstrated. So that's my area of responsibility. So I think we would expect that once the technology demonstration missions are funded and executed, then other programs in ESA could actually use those capabilities concurrently. And that then will be driven by the science community.
Okay, so you mentioned that you will do some research on the different resources you have on the lunar surface, and in the past I've heard that, like for example, the helium-3 isotope, I don't know whether you have heard of it or not, that we rarely have right here on our Earth, that can be found on the lunar surface with much higher quantities. For example, are you planning to examine also these things in particular, or are you planning to do research on the lunar surface and materials in general, or do you really have some goals you want to achieve or materials that you want to examine?
Yeah, so probably not helium-3, but you saw the VMMO concept there was addressing particularly volatiles, and of course we want to know the water ice abundance and look at what minerals are available on the lunar surface as well. So that's the priority, I believe, for now, but that's not to say helium-3 would be useful for future resource exploitation, as you say. That's not currently in the plan, but if you can think of a nice concept, please get in touch with us and we'll be happy to hear about it.
Okay, thank you very much.
Okay, unless there's anything else, I'd like to thank you. Thank you.